It's also used to look at program evaluation and cost-benefit analysis, because sometimes it's easier to look at what something does badly as opposed to something that it does well, because people are always focusing on what things are good and well, and so you'll have a potential big list of the benefits to some program or some process, where when you look at the negative, sometimes that brings out some more interesting insights. And so I've kind of already touched on this slide, is that in a way, since we've created a target that solicits false positives, which I'll talk about more, and so that allows you to do what would potentially be some passive reverse engineering. The target potentially causes massive false positives in the scanners, and then you can see which ones of their detection signatures will basically trigger on next to nothing, and I'll talk about that more in more detail as we go. Here's just kind of a little graphic of how we think about detection accuracy as a concept. So you have positive detection, that the vulnerability is there and you detected it. So that's the most, or hopefully the most common case. That's what you're really looking for. That's where you want to be, is in that section of where the scanner's detecting it and it was actually there. Which, when you go down the box into the false positive range, it's where you said it was there, but it actually wasn't. Where and actually with the false negative is where you're actually should be most concerned about, is like that you've not detected it, but it really is there. So I'll talk more about the importance of false negative rates, because that's one thing you don't necessarily know with one scanner, is how do you know what you don't know? You run a scanner against an app and it says these vulnerabilities are there. When you fix those, there's potentially vulnerabilities you haven't found, the scanners haven't found. But that's what can potentially catch you, is because then you put the application on the internet and hackers find it, and that certainly undermines what you're trying to do with testing before putting it on the internet. So here's just another slide about benchmarking. And positive benchmarking is just where you're trying to measure, the valid results, and you get some type of, idea of how accurate the product is. There's various limitations to benchmarking. Selection bias, being one of them, that you basically get what you're trying to look for. So you pick a target that has certain vulnerabilities, and you're going to find those. But if there's other potential vulnerabilities there, and you miss them, you're kind of missing the point of it. There's also problems with interpreting the data, and ultimately when you're looking at the results, you can make errors, and so some of the these are just some of the problems that benchmarking has. So ultimately, our rationale for reverse benchmarking was that false positive types with scanners, when both Tom and I started looking at them, haven't really changed. Like a lot of the signatures that would be false positives back in the late 90s and early 2000 are still present today, and I'll talk more about that when we get to the actual results. And because of the nature of HTTP and the scanners, you have this statelessness that itself causes some of the false positives.
Can you explain that a little bit more, like what you mean by the testing mechanisms are stateless?
The scanner, when you're going through and scanning an individual signature, doesn't necessarily know what comes after it. It knows it sends a request, and then what it gets back, it interprets. But it's not really maintaining the signature itself isn't aware of the state, so it can get out of sync with the response that it gets. And so I'll actually talk about that more specifically when we get into the different false positive types that we're talking about. And then also there's just also little research done around false positives and what causes them, because other scanner technology or any signature-based technology, IDSs or network security scanners, even though the web app scanners and the network security scanners are starting to converge now in the marketplace, they're all based inherently on signatures. And so if those signatures are flawed, those flaws stay around. And so it's just there's top 10 lists for types of vulnerabilities and stuff like that, but there's no real research that's been done. And that was one of the reasons that we started doing this, is just there's not a lot of talk about false positives and false positive types, because ultimately what's the alternative to signature-based technology for security? I don't see there being any real technology on the horizon that's going to make signatures obsolete. So even back in the day with Paycheck's insertion, evasion, and denial of service paper, where he talked about endemic problems with intrusion detection systems and how you could fool them. Those types of problems based with signature technology haven't been improved. So in some ways we're why is it that we haven't made any progress? Certainly they've gotten more expensive and they detect more things and they have a big fancy GUI and their price tag goes up. But at the atomic level, the signatures, haven't, really been increased in complexity. And so this is just kind of the overall methodology, is that, we're trying to solicit false positives from the application with a sample web app that has specific pages and functionality that are designed to cause those false positives within the scanners. Ultimately, we're not trying to malign the vendors. Like, I'm not going to be telling you which scanner had which results. You can probably figure it out just by order of elimination. But because ultimately we want them to increase their technology, because ultimately as a user of the products, I'd rather not have to QA them for them. So, the main vendors have, put in functionality where you can submit a false positive to them, but the time it takes to submit that and send it to them and to do the back and forth with them about it being a false positive or not being a false positive and the semantics surrounding that, it's just not worth your time to try to do that for them. And ultimately, they're never happy about it. And so, this is one way. We've also given the target to this, last year we gave the target to some of the vendors, and ultimately in the results you'll see that at least one of them has improved somewhat over the course of the year. So here's just a diagram about a high level how the target works. You have a web application scanner. It then is pointed at this reverse benchmarking target, and it scans it like it would any other web app. It crawls it. It has the pages. It goes through the various login functionality and stuff like that, and then we get results and we analyze the results. Ultimately the scope of this is your kind of unsophisticated user and out-of-box scanning configuration. So we didn't try to set up custom 404s with detection with the scanner or anything like that. We just out of the box, the default policy that the scanner uses, ran that against the target as kind of the baseline. So the baseline is just default configuration and their default policy settings.